look into domain and range of basic trigonometric functions. That is, domain and range for sine, cos, and tan. Yeah, let's start with sine x. F of x equal to sine x. Let's find the domain and range for this function. Dom f means what can we, domain, remember, is about the input. What can we put inside the sine function such that when we punch calculator, we'll see our answer. What can we put as x? Anything goes as x. Everything will work. 200, 2,000, minus 4,000, 1 million. Everything you punch for sine, anything must give you an answer. Because anything can work, we shall say that the domain is all real number. Also written in this interval notation as this. Very simple. Let's discuss the range. The range R sub f is equal to what? The range is possible output we can get from a sine function. If you go ahead and check sine anything, there's never a time you can punch sine of a function, sine of something, and you have 2 as your answer. You can't punch something, sine anything. Check it out. You have 5. Sine of anything you punch, you will see 0.00, 0 points, or minus 0 points. Highest you can see is 1. Yes, highest 1. The lowest minus 1. So I'm saying that the range of sine function will start from minus 1. Yes, it can be minus 1 down to 1. Yes. Pause the video. So the range of sine x is minus 1 down to 1. Yes. Yes. So sine of anything, the maximum number you can get is 1. For instance, when you punch sine 90, you have 1. Or when you punch sine 270, you have minus 1. Now from these 2 values, the rest will give you 0 point something, 0 point something. Maximum value for the sine function is 1. Meanwhile, the lowest number you can obtain from the sine function is minus 1. Yes. Actually, it's not only 90. There are some other values like sine 450. Sine 450 will also give you 1. In fact, to know them, just know that when you have your pi over 2 plus 2 pi k, where k is an integer, this gives you the numbers that will be giving you 1. Yes. Yes. And also this one, the one that will give you minus 1 is not only 270. Also, when you check out 3 pi over 2 plus 2 pi k, when you check out this, you'll be having the values that will be giving you minus 1. Yes. This k means an integer. It could be 0, it could be 1, it could be minus 1. Take note. So this value is here, your pi is 180. Pi, yes, pi is 180 in radians. Pi is 180. So 180 over 2 gives me 90. So when k, let's say when k is 0, I will have 180 over 2. Here is out. That gives me 90. So these 2 things will give you your endpoints. But from these 2 things here, everything you'll get must be in between -1 and 1. That's why we say the range of sine x is from -1 down to 1. It can't go above 1. You can never get an answer from the sine function that will give you 2. Please take notes. So quickly, let's look into the cos function, the domain and range for cos. First of all, let me clean the board. So let's talk about the cos function. Domain for this function, dom f, d sub f. Domain are those possible values we can put in as x in the cos function, so that when we punch cos of that value, we must have an answer. So what could s be? Actually, s could be anything. Just like in the sine function, domain for sine is also domain for cos. And everything works for cos. Everything works. Therefore, our domain is going to be all real numbers. Remember, it's also written like this. Minus infinity down to infinity. Yes. Now the range of cos function, the range r sub f is equal to, the range of the cos function is similar to that of sine x. In fact, once you know sine function, the range of the sine function, I am certain you also know the range of the cos function. So with that being said, now you know that the range of the cos function is going to be s, such that -1 is less or equal to s, as x is less or equal to 1. This thing means that the range is in between -1 and 1. I gave you in set builder form. I can still give you in the form you know already, which is the interval notation, -1 down to 1. We close to show that -1 and 1 could be a value. So in the cos function, the maximum value we can have from the cos function is 1. Yes. For instance, when you check out cos 0 is 1. In fact, how do you know the values that we're giving you 1 from the cos function? Let me give you an idea. Whenever you have your x to be equal to, whenever your x is equal to 2 pi k, yes, whenever your x is 2 pi k, you have 1. So if k is an integer, please take note. K is an integer, meaning that k could be -1, -2, +1, +2, or even 0. Refer to real number system in our video to understand what we mean by integers. So now, you know, when k is 2, we have 2 times 180. Pi radian is 180. So 2 times 180, that is 2 times 180, that's 360. Times 2 again, that's 720. So when we do cos 720, we expect our answer to give us 1. Yes. Now how about -1? When you have something like this, let's say x is equal to pi plus 2k pi. I can say pi plus 2 pi k. When you have this, the numbers you will obtain, the value you will obtain are the values that will give you -1. The rest values must be in between -1 and 1. Yeah. So tell me a number you think that can give us equal to -1. Let's check. What if we have here now as k at 0? That becomes 2 times k, 0 times 1. Here will be out. So at s equal to pi, when you punch cos 180, you will see your answer as -1. Just know that the range of cos function is from -1 down to 1. Yes. So quickly, let's discuss domain and range for the tan function. But first, let me clean the board. Yeah. So quickly, let's look into domain and range for the tan function. Yes. There's something about tan function. It's not like sine and cos. Tan function actually can be expressed in terms of sine x and cos x. So tan function is equal to sine x all over cos x. Meaning that the tan function is now a rational function, like a fraction, where we don't allow the under to be 0. In that case, we are not going to allow cos s to give us 0. Therefore, those numbers, those values of x that will make cos x 0, we shall remove them. Yes, there are some numbers that one will do cos of that number, we will see 0. Example of such number is 90. Cos 90 is what? Check it out. You see that the answer is 0. So our domain of this function, dom f is all real numbers except where s is such that. Now, actually, it's not only 90 that can make here 0. Yeah, it's not only 90 that can make here 0. Apart from 90, we have other numbers that can still make cos s equal to 0. Yes. For instance, 810. Check out cos 810 on your calculator. You'll see that the answer is 0. So all the numbers that will make cos s 0, we shall remove them. There are millions of numbers that can make the under 0. So we have to remove all of them from our domain, because domain contains the parts that will work. And we are saying that everywhere we work, this one alone is false. Here means everything will work, which is false. We know that some things will not work. Example, tan 90, you will see mass error. Tan 810, tan 810, you will see what? Mass error. So what are these things that will not work? Let me show you. When s is equal to things that will not work, when s is equal to, let's say we have pi over 2 plus pi k, where k is an integer. Yes, k is an integer. Yeah, where k is an integer, meaning k can be minus 1 or 1, minus 2 or 2, or even 0. Whole numbers, both what? Negative. Check out our video on real number system for more idea on this. So when we have x to take any of these values, for instance now, let's say k is 1. 1 times 180, 180. If k is 1, because 1 is an integer. 1 times 180, 180. Yes. Because pi is 180 in radians. So here it's pi over 2, that's 90. So 90 plus 180. What's the answer? 270. When you punch cos 270, you must see what? 0. Making tan 270 to give us mass error. So all these things, we shall remove them to find the domain of tan s. So everything will work except when s is equal to this. Yes, everything will work except when s is equal to all these things. Can I write it here? When s is equal to pi over 2 plus pi k. Yes. Remember, S is an element of real number. And K, yes, K, please note, K is a member of integers. K is a member of integers. That is my domain. What will work are those numbers that will not make cos x 0. Those ones will work. So they are here. Everything in here will work except this point where s is equal to this. Yeah. So now let's talk about the range. The range of tan s. The range of tan s Rf. R sub f is equal to, for tan s, actually tan s is not like cos s and sin x. Here we'll see the range is from -1 to 1. Tan s can have any output. Anything can be the output for tan s. Therefore, we shall say that the range of tan x is going to be from -infinity down to infinity. Always open, always open. I hope this class was helpful. Once more, I am Holget Emmanuel, and this is the Nestra class. Thank you.